I am David, your developer on duty, and in this video we will see how to create macros in Nim. Let's start with a fresh Nimble project. Nimble init and then macros. It will be a binary. Initial version is okay. Some macro tests. MIT, and that's it. So let's first start with what we want to achieve today. I open my generated file called macros.nim and remove this generated content. Now what I want to have is to have a type called entity, which is a ref object of root object. And once I have this entity, I want to be able to define my own entities called, for example, book. So ref object of entity. And then I want to define my fields. For example, ID is an integer, name is a string, and important is also a string. And once I've done that, I want to be able to do something like book get table name, as well as book get columns, and I want to see if some fields have some special annotations, and for these annotations I use Pragmas. So I want to be able to say, for example, that this is read only and that this is read only and mandatory. So in the end I will be able to write book is read only of name, and that should be true. And the same with is mandatory. Let's remove those compiler errors by creating the Pragmas. So we write template, read only, and that shall be a Pragma, as well as mandatory. Let's create our implementation of the get table name function. So for this we need to create a function called get table name. And as you can see, it acts on the type and not on an instance. So we have to write type description of entity. And we want to return a string. And the implementation is easy. We just write $e. Dollar is the operator to get the string out of e. And we want to echo it and run it. And you can see we got our book. Now let's implement get columns. So again, we create a function, but before we do that, we need to define our type, what a column is. So type column shall be an object with a name property of type string and the type property also of type string. Now we can create our function get columns. And again, it acts on the type itself. So we write type description of entity, and it returns a sequence of columns. And the implementation is as follows. First, we create an instance of it by writing var x equals to new e. Now we have an instance of our entity, in this case book. And then we write for field while in x.field pairs. Result add column name shall be field and type shall be dollar operator type of var. And now we can write for column in columns echo column.name column.type, and let's see if that works. And you can see that we have our ID of type integer, name of type string, and important of type string. Now before we create our function to check if a field is read-only or mandatory, we need to create a helper macro to get all the pragmas of our entity. And for this we need to import the package macros. And that's a problem because our own package is called macros, so we have to rename it. So we rename it to entity macros.nim, as well as in the nimble package. And now we can create our macro, get Pragmas, takes a t as a type description of entity, and returns a block of code called untyped. Then we can write let my tree impl equals to t get type inst of 1 dot get impl. And now to see how that looks like, we can write echo my tree impl dot tree wrapper. So let's compile it. Nim run source entity macros nim. And we have to call it, of course. So we write book get Pragmas. And now you can see the tree structure here. So it begins with a type definition. We have sim book, ref type, object type, rec list. And here we have our ident defs. And you can see all the Pragma information is already there. So it's a little bit scary and we have to destructure it somehow. And one nice way to do that is using pattern matching. To enable pattern matching, we have to import fusion/matching. And Fusion is the package which will maybe at some point, or parts of it will maybe some point end up in the standard library, and it's a great place to have some experiments. And one experiment is the pattern matching library, and let's use it in our get Pragmas macro. So we can write if my tree implementation matches. And now we have to pattern match, and we have to look at the tree on the right. So it starts with a type def, so we write type def, and we don't care about the first and the second parameter, so we just write underscore, and then it continues with a ref type, so we write ref type, and then it continues with the object type, so we write object type. Now you know the drill. So again, first and second we don't care about. Then we have a rec list. And inside that rec list, we want all of those ident defs. So we just write all ident defs, and this one will be available as a variable afterwards. So we just close the brackets. And here we have now access to ident defs. Now let's continue with this tedious work. So we have now access to ident def, and we can create a for loop. So for ident def in ident defs. And now we have to match again. If ident def matches ident defs of Pragma expression, and now I want all prags, and I don't care about the other ones. And now we have access to prags, so we can write if prags 0 matches ident, and ident shall be is ident, and prags 1 matches Pragma of all sim is sim. And then we can loop over all sim, so for single sim in sim. And here we have our first Pragma. Let's see if this works. So we can echo our single sim dot tree representation. So let's run it. And you can see we get our read-only, and mandatory Pragmas. That's perfect. So now we can actually construct our Pragmas, but for this we need to define a type first. So type Pragma shall be an object with a name property of type string, and every Pragma has a corresponding field name, so we write field also of type string. Now we can instantiate our sequence of Pragmas here. So we have Pragmas as a sequence of Pragma, and that shall be an empty array in the beginning. And here, as we have all the information, we can construct our Pragma. So we write var Pragma equals to Pragma, and our name shall be single sim dot string value, because we know it's a string and we have to convert it to a string value. And the other one is field name. No, just field. Field shall be ident.string value. And now we can write pragmas.add Pragma. And in the end, we can just echo our Pragmas to see if it works. And you can see we have name read only of field name, name read only of field important, and name mandatory with field important. Now instead of echoing, let's return it. And the easiest way is to write return quote do, and then we can have access to our variable Pragmas by writing Pragmas. Now let's see if that works. So we write var x equal to book get Pragmas, and let's see what x is. And you can see we get our Pragmas. Let's create another helper procedure called has Pragma. Takes a type description of entity, the field of type string, and the Pragma of type string. And it will check if that field has a certain Pragma, and the result will be bool. So we can write const Pragmas equals to e get Pragmas. And we can write const here because we know that information at compile time. And to see if that field has that Pragma, we return Pragmas any. And I want to use here this arrow function syntax. So we need to import sugar, and we need to import secutils. So if any Pragma with the same field and with the same name exists, then I return true. So let's try this out. I want to say book has Pragma. The field shall be name, and the Pragma shall be read only. And I want to echo it. And you can see that's true. Now we have everything we need to create our functions is mandatory and is read only. So we write prog is read only. Takes a type description of entity, a field of type string, and returns a bool. And in this function, we just have to return e has Pragma field with read only. And the same thing holds also for is mandatory. And we just have to change this here to mandatory. Now let's assert that this is correct. So we assert that book is read only, name is true, and that mandatory important is true. And we can also assert that important is also read only. So let's run this, and it worked. I hope I could show you that it's relatively easy to create some helper functions which act directly on a type definition, also using macros and pattern matching. Thanks goes also to those developers who created the norm package, which I've also shown in my last video because I took a lot of inspiration from it. Thanks for watching. Stay tuned.